Hello and welcome to the end-to-end deployment of Open Private 5G on-demand screencast. This demonstration covers the necessary software, equipment, and configuration to be made in order to build the private 5G network. We are providing the complete list of the required hardware. In addition to that, we are providing the ready-to-use OpenNebula appliances. These are the pre-installed virtual machines that contain all the necessary software, reducing setup time and manual configuration errors. This solution is built entirely of the open source software components. This guarantees transparency, avoids vendor lock, and gives you the freedom to customize. The entire system is orchestrated by the OpenNebula frontend, which is running on a dedicated external server. This is the management plane for our cloud infrastructure. The frontend manages resources of Dell's server that is configured as a KVM host. It also hosts all the virtualized network services. On this KVM node, we deploy the key 5G components, such as two pre-installed virtual machines. First appliance contains Open5GS, which provides a complete set of 5G core network functions. The second contains the SRS RAN project, an open source software suite that acts as the processing layer for the radio access network. To ensure high-speed communication between them, the data path is accelerated using DPDK. Next, we address the critical link between our virtualized RAN and the physical radio hardware. The SRS RAN virtual machine connects to a specialized Intel network interface card using PCI pass-through. This advanced technique gives to the VM direct hardware access, bypassing the hypervisor to achieve the ultra-low latency needed for real-time radio processing. This network card is then cabled directly to the radio unit, which communicates wirelessly with the end-user device, represented with a 5G smartphone. Finally, to provide a complete connection, the Open5GS core is bridged to external networks, which gives the user's device access to the internet or other private networks. In this platform-centric view, you can see how OpenNebula serves as the fundamental layer that automates and simplifies the deployment of the virtualized 5G mobile network. Here you can find the list with the specified hardware. For radio components, we are using standards-compliant Light-ION O-RAN radio unit and a commercial off-the-shelf cross-call 5G smartphone as the user device. The entire virtualized stack runs on a powerful Dell PowerEdge R750 server, configured with an Intel Xeon Gold processor and fast NVMe storage to act as our hypervisor host. Finally, for networking, we are using the specialized Intel E810 network card with precise timing capabilities to connect to the radio unit, while a high-speed Broadcom 25 gigabit adapter handles general data connectivity. We begin by installing the OpenNebula cloud itself. This is made simple using the OneDeploy automation tool. As the proper timing is absolutely essential for an O-RAN network to function correctly, the critical pre-flight check is performed. We are verifying the synchronization status of the radio unit. With the infrastructure validated, we deploy the main services. This is as simple as instantiating two pre-built virtual machine appliances, one for SRS RAN to run the O-RAN functions and another one for Open5GS, which provides the 5G core. We test the end-to-end connectivity. This involves making a data call from the user device all the way through our new private network to the internet, confirming that the entire system works as expected. OpenNebula is already running in the environment. This screencast is not going to cover the deployment of OpenNebula using the OneDeploy toolchain. In the project repository folder, we are going to find all the scripts that are necessary to be launched on the KVM host. These scripts will ensure that the host has all the necessary software installed. The first script is going to ensure that the network card driver is in place. The second script is going to ensure that the Linux PTP that is used for synchronization is installed as well. The third script is going to create and configure the virtual network function for the network card. The SRS RAN virtual machine is going to utilize it via the PCI pass-through. The fourth script is going to ensure the configuration of the PTP Grandmaster. The last script to run is made for KVM performance and optimization tuning. Once the KVM host is configured, we are going to connect to the light on radio unit. Using the show running config, we can list the current configuration of the radio unit. It's important to also verify the PTP sync state of the radio unit. By looking at the spectrum analyzer, you can see that there is no signal broadcasted on the 3.8 GHz spectrum. In the OpenNebula Sunstone interface, by navigating to the Infrastructure Host tab, you can verify that the PCI device pass-through is enabled and configured correctly. In the VM template section, you can find two tailored virtual machine templates that were built exclusively for this project, the Open5GS and the SRS RAN templates. In order to automate the deployment, these templates are going to leverage the OpenNebula's built-in contextualization functionality. As an example, let's navigate to the SRS RAN user input section. You can find different variables that are going to be passed in the form of environment variables to the virtual machine. The default values are already applied, but you can fine-tune them anytime. By taking a look at the VMs tab, you're able to find two virtual machines that are already running. The SRS RAN is configured with two networks. One is for management and the other is to connect the core with the radio. In the PCA tab, you're able to verify the pass-through device. The Open5GS VM can be much more lightweight and has been configured with less resources. Same as SRS RAN, the Open5GS has two virtual network cards attached to two different virtual networks. Let's establish the communication with SRS RAN VM and let's make sure that the software is not running. As seen in the output, the software isn't active. Using the show configuration shell script, we can print and inspect the current configuration. Since the SRS RAN is not running and in order to use it, we must start it first. Let's print out the configuration once again and verify that the SRS RAN software is running. Now we're going to connect to the 5G virtual machine and verify that all the necessary services are running. Also, we must verify that the SRS RAN node has been connected. By navigating to the 5GS web-based dashboard, we can confirm that the UI has been provisioned. Going back to the spectrum analyzer, we can verify that the frequency is now occupied with the radio unit and it is transmitting the signal. To conduct the real-life test, we have the phone terminal that is currently in the airplane mode. Let's take it out and conduct the test. Different register messages are now displayed. That's a signal that the mobile is now connected to the network. In the browser, let's access the OpenNebula web page. As you can see, it's fully functional. For the performance test, let's utilize the speed test. Now switching back to the spectrum analyzer, you can see that the full bandwidth is being utilized for the transmission. This screencast was produced in the scope of One Edge 5G project. Thank you for watching and see you in the next screencast.